So in the last video, we started talking about quadratics, and we talked about how to find the roots of a quadratic. So let's take a look at that again. So we talked about three ways of finding the roots of a quadratic. The first one is graphing, okay? Remember, the roots of a quadratic are the x-intercepts, unless it never crosses the x-axis. If it never crosses the x-axis, then those roots are simply roots. It's where the y is equal to 0, and those roots would be imaginary. Here, I gave an example of a quadratic that does cross the x-axis. So our roots are our x-intercepts, okay? And one thing that you could see here is that, sorry, this graph is getting crazy. One thing that you can see here is that when we try and find these roots by graphing, that can actually be really difficult because we have to approximate. Both of these roots have decimal values. They are not perfect. You can see this root here is negative 4.098. That would be very hard for you to approximate without some sort of special tool. The same thing with this one. This is 1.098. Very hard to approximate without an extra tool. So graphing can work, but it's not very accurate, okay? We have some other options, right? We talked in the last video about factoring. And the problem that we found with factoring is that it can be very quick, but it doesn't always work. Not every quadratic is factorable. And then the last thing that we talked about is the quadratic formula. And the quadratic formula does always work. We can always use it. That's not a problem, okay? So let's just summarize what we said there, okay? So this, completing the square, helps us find the roots of a quadratic. And there are two advantages, okay? The first advantage is it always works. And the second advantage is that it helps us find the quadratic in vertex form. Which we're not going to talk about all that much today, but vertex form tells us a lot more about a quadratic. It tells us its vertex. It tells us how narrow it is or how wide. You can't tell that from the ax squared plus bx plus c, which is standard form. Okay, so vertex form, if we go back to that graph for a second, this is vertex, this is standard form, our ax squared plus bx plus c. But when we have it in vertex form, what that will tell us is it will tell us the exact location of the vertex, and it tells us whether or not this graph is very narrow or very wide. Okay, this doesn't tell us that at all. The only thing that we can figure out from here is the y-intercept, because we set x equal to 0 and we get negative 9. So we could see here that the y-intercept is negative 9. So this is a huge advantage for completing the square when we want to attempt to graph our quadratic, or if we just want some more information about it. We said other ways to find the roots. We talked about 3. Completing the square is the fourth. So we can do it by graphing, but this is not accurate. Okay, sometimes it will be if you have these roots that are integers, but most of the time that doesn't happen. In our last video, we spent a lot of time on factoring. This is fast, but it can't be done if the quadratic is prime, meaning it's not factorable, right? And finally, we talked about the quadratic formula. And the quadratic formula always works. It's just that you have to remember the formula. Okay, and maybe at some point I'll make a separate video. The quadratic formula actually comes from completing the square. If you complete the square, you are using the quadratic formula. So this is sort of the process of how to derive it. Okay, when we go through that, just keep that in mind. Okay, so let's talk a little bit about what completing the square is. I'm going to show it to you visually, and then we're just going to do a bunch of examples. Okay, so visually what's happening is think of your quadratic as if it's the area of a rectangle. So you're forming a rectangle. So this is a visual explanation of completing the square. Now we're completing the square, so from this rectangle, what we're going to do is we're actually going to form a square. So I'm going to cut it off at about a square, so hopefully this will look okay. Okay, so we cut it off at about a square. And then what we're going to do is we're going to cut the bottom in half. Okay, so we're going to take this and we're going to cut it in half. And then this bottom rectangle, this piece right here, okay, we're going to rotate this. So we're going to actually pick it up and we're going to move it over to the side. And we already know that this length here is the same as this length here. How do we know that? This is a square, and a square, all sides are equal. This horizontal length has to be equal because it's in the same rectangle. So if this length is equal to this one, then it's also equal to the vertical, okay, because it's a square. So we're going to take that and we're going to pick it up. And we're going to move it over here. Okay, and what we know is that this length here is now equal to this length here. How do we know that? We cut this in half. So this distance is equal to this one. Whoops. This distance here is equal to this one. Okay, so I'm just going to put a line through it so that you know that they're equal. And that means that that was brought up here. So the square plus this distance is the square plus this distance. So now these two are the same, which means that we have actually formed a square here. Okay, here's our square. Now I'm going to put this in a nice bright color so that you could see it. Here's our square. Okay, so you can see it. We have a nice big square. The problem is that that square creates an extra piece that was not originally part of the quadratic. Now what this means is when we complete the square, we always have to get rid of an extra piece. Because we don't want to change the actual quadratic. Okay, all we did originally is we took what was already there and we just moved it around. That's fine. But by creating this square, now there's this extra piece that we have to get rid of, okay? So let's take this and move it from geometric to algebraic. So we're going to take a simple quadratic. And we're just going to complete the square with it, okay? And we'll go through the steps and we'll do this a few times. I'm going to start with an a equal to 1, okay? So again, it's not that different when a is equal to 1 and a is greater than 1, but just like factoring, there's like an extra step in there. So we want to make sure that we don't ignore that extra step. So if a is equal to 1, so what we're going to do is we're going to start with something simple. We're going to start with x squared plus 6x plus 8. And right now we're just going to complete the square. After we complete the square, then we'll talk about solving for the roots. Okay. So we're completing the square, which means that something is being squared. So what we're going to do is we're just going to set up the fact that we're squaring something. So then the next question is, okay, well, what are we squaring? Okay, well, the idea is that we're going to start by working with these first two terms, because these first two terms are what give us the x's, okay? So if we're working with that, what we're going to do is we're going to say, how can we get x squared plus 6x using a square? And the way that we do that is we do x plus 3 squared, okay? Why is it plus 3? So I'm going to put this over to the side as like a little side note so that you can see what's going on. So x plus 3 squared is the same thing as x plus 3 times x plus 3. So notice what's happening here. When we multiply this, we get x squared, and then we get the 3x twice. Right? We're adding 3x to itself 2 times because we have the 3x from these inner terms and we have the 3x from these outer terms. So we get 3x twice, and that's going to be true no matter what this number is. We're going to cut it in half because we're going to get that twice. If this had been x squared plus 8x, we would have done x plus 4 because x plus 4 squared would give us x plus 4 times x plus 4, which is x squared plus 4x plus 4x. And we'll see an example of this. Now here's the thing. Here's what you're going to notice. X plus 3 squared doesn't just give us x squared plus 6x, right? It gives us an extra piece. It gives us a plus 9. Because we have to multiply these last terms. So we get an extra plus 9 here. This plus 9 is our extra piece because we don't see a plus 9 in the original quadratic, right? In the original quadratic, there's just x squared plus 6x. So in order to get rid of the 9, we have to subtract it. Okay? So x plus 3 squared minus 9. This whole thing is equal to x squared plus 6x, right? We know that x plus 3 squared gives us x squared plus 6x plus 9. When we subtract the 9, right, plus 9 minus 9 makes the 9 go away, and we're just left with x squared plus 6x. So we take the x plus 3 squared, we subtract the 9, that gives us our first 2 terms, and now we just bring down the last. We bring down the constant. And that's going to give us, we combine like terms, that's going to give us x plus 3 squared minus 1. And we're done. We've completed the square. okay? If we want to solve, so this is the quadratic in vertex form. We're going to be talking about this at another time in more detail. But this is the quadratic in vertex form, and if you wanted to find the vertex, the x value of the vertex is -3, so we flip this, and the y value of the vertex is -1, so we flip the x, we don't flip the y. But don't worry about that so much, we're going to talk about that much more later. Okay, so we're done completing the square. To solve for the roots, we set equal to 0 and we solve. Okay, so we would say x plus 3 squared minus 1 is equal to 0. To solve, we would add 1 to both sides. This would give us x plus 3 squared is equal to 1. We would take the square root of both sides. And this is a big thing. When we take the square root, we always have to do plus or minus. Okay? So we need plus or minus because the square root of 9 is 3 or it's -3. Okay? When we take the square root, we always do plus or minus. The only time that we wouldn't is if it were like a modeling problem where it's asking you what is the distance of something. Then you're not going to have a negative distance. So you wouldn't take the plus or minus. You would just take the positive square root. Okay? What this leaves you with is x plus 3 is equal to plus or minus 1. The square root of 1 is 1, so we may as well just write that. And then we can subtract 3 from both sides. We get that x is equal to -3 plus or minus 1. Now, if you couldn't simplify this, you can leave it like this. This shows you 2 roots, though, and we can simplify this. So either x equals -3 plus 1, which is -2, or x equals -3 minus 1, which is -4. Now, if we put this into the quadratic formula, we would get x equals -2 or x equals -4. If we factor this, you can see that it factors to x plus 4, x plus 2. So this was factorable. And factoring is going to be much faster than completing the square in many cases. It's just that it won't always work. So we have to know how to complete the square. Okay, so let's just summarize what we did in this, and then we'll do another example. So this is the process. So go back here. The first thing that we did is we wrote the parentheses with the square, right? Because we knew that we were going to square something. And then what went in here is x plus, and then we took the b over 2, and the b over 2 was positive, okay? So we took this b and we divided by 2 because when we square it, we get the same thing twice, okay? And that's what gives us the b. So we write a parentheses with a square. And then inside the parentheses, is x plus our b over 2. Because when we take x plus b over 2 and we square it, we're going to get the first two terms, but then we're going to have to subtract something. The thing that we have to subtract is this number squared, right? Because when we square x plus 3, we're going to have x plus 3 times x plus 3, and that little extra piece that we get, right? Geometrically, that's your extra piece over here. The little extra piece that we get is this 3 times 3, which is a 9. So this gives us the a term, it gives us the b term, and then it gives us something extra. So we're subtracting something extra. That something extra is just this b over 2, this 3, squared. You are always subtracting. It's always something extra. That's because even if what's in here is x minus something, when you square it, it becomes positive. So we always subtract. We're always getting rid of a piece. Okay. Then we add the c value to the end. Essentially, you're just bringing down the c. And your last step is just to combine like terms. Okay. This is if a equals 1. So we're going to do some examples, some more examples of where a is equal to 1. And then we'll do some examples where a is equal to something more than 1. Okay? Okay, so let's do a bunch of examples. So let's say that we have x squared plus 10x minus 3. So not factorable. There are no factors of 3 that give us 10. So factoring is out of the question. Okay, so we have to complete the square. So our first step is to write down our parentheses and square it. Inside of this goes x plus 5. So we take the 10 and we divide by 2. Okay, now what's the extra piece that this creates? Well, x plus 5 squared, and you don't have to write this out every time. I'm just showing you for a couple of them so that you see why we're doing what we're doing. X plus 5 squared gives us x plus 5 times x plus 5, which gives us x squared plus 5x twice, right? So we're adding the same thing to itself twice. That's how we get the 10x, and that's why we divide by 2. But then this gives us an extra piece. This gives us a plus 25. How did we get that plus 25? We got it from doing the 5 times 5. So what do we get here? X squared plus 5x plus 5x gives us x squared plus 10x, which is what we want. But then we have this extra piece, which is a plus 25. So what do we have to do? We have to subtract that extra piece. So we're going to subtract 25 from here. So x plus 5 squared minus 25 is x squared plus 10x. But then we still have this minus 3. So we have to include it. And now we combine like terms. So x plus 5 squared minus 28. Okay, so we've completed the square at this point. Let's solve for the roots. So in order to solve for the roots, we set it equal to 0. Remember, the roots are where your y is equal to 0. So if your y is x plus 5 squared minus 28, then we're looking for where that's equal to 0. Okay, and we're solving for x. So we need to get x by itself, which means we have to get rid of this 28 first. So we're going to add it to both sides. Okay, that gives us x plus 5 squared is equal to 28. Then we have this square that we have to get rid of. So we're going to take the square root of both sides. And remember, when we take the square root of both sides, we always want a plus or minus in front of here, in front of the square root. Okay? That's what gives you the two roots. Now, we talked about the fact that some quadratics have just one root. So the only way that you could get one root is if this were equal to 0, because then plus or minus 0 makes no difference. So what does this give us? This gives us x plus 5 is equal to plus or minus the square root of 28. And you have a choice. You could simplify your square root now, or you could simplify it afterwards. Let's simplify it afterwards. Let's do all of our simplification at the end. So we subtract 5 from both sides. And that gives us that x is equal to negative 5 plus or minus the square root of 28. And we're almost done, right? We can't combine a number and a radical, but this radical does simplify, okay? So we want to make sure that we simplify the radicals. So we did this with complex numbers. We're looking for the highest factor that's a perfect square. So the largest factor that's a perfect square here is 4. So this is negative 5 plus or minus square root of 4 square root of 7. And the square root of 4 is just 2. And you can leave your final answer like this. These are your roots. Okay, this is your final answer. Do we have any? So hopefully there are no questions here. Okay, let's take another one where we're completing the square with an a that's equal to 1. Let's do x squared plus, let's actually change that to a minus because we haven't done any minus. X squared minus 14x plus 10. Okay. So once again, we draw our little parentheses. Inside, we're going to have x. And then our b is negative 14. So when we divide by 2, it becomes negative 7. So this is a minus 7. Okay, we have an extra piece. So again, and this is the last time I'm going to show this, okay? Off to the side, x minus 7 squared is x minus 7 times x minus 7. You can see that we get x squared minus 7x minus 7x, right? We get 2 negative 7x 2 negative 7x's, which gives us a negative 14x. And then if we multiply the last two terms, notice negative 7 times negative 7 is positive 49. So you still get an extra piece that needs subtracting. Okay, what this gives you is x squared minus 14x plus 49. But this is extra. So we're going to subtract it. So you always subtract. Doesn't matter if inside your parentheses you have a minus sign. Okay, and then plus 10. So this gives us x minus 7 squared minus 39. Okay, and once again, we'll solve for the roots here. I won't do this for the next one. We get x minus 7 squared minus 39 is equal to 0. So we add the 39 to both sides. That gets rid of the 39. We want to isolate what's being squared. That gives us x minus 7 squared is equal to 39. And then we're going to take the square root of both sides. So once again, remember, you need a plus or minus. So plus or minus, okay, positive square root or negative square root. So that gives us that x minus 7 is equal to plus or minus the square root of 39. We can add 7 to both sides. And our final answer for our roots is x equals 7 plus or minus square root of 39. So you're done here. Square root of 39 can't be reduced. 39, the only factors are 13 and 3. And 13 and 3 aren't perfect squares. So you can leave your answer like this. The only time that you have to go further is 1, to reduce this, and 2, if you get an integer here, like if you had gotten a 3, then you should go and do 7 plus 3 and 7 minus 3. You should actually calculate it, okay? But otherwise, you can leave it like this. If this were a negative square root, you'd have to pull out an I, just like we did when we did when we used the quadratic formula. Okay. Let's do one more. This is our fourth example, really, because we did one to demonstrate how to complete the square. So one more with an a that's equal to 1. Let's do x squared minus 9x plus 7. Actually, let's do minus 7. Why not? Okay. Okay, so same process. Okay, 9x, negative 9x. We want to divide by 2. So here's the thing. We divide by 2, we don't get an integer. That's okay, doesn't matter. You can do it so that you can even convert it to a decimal, because 9 divided by 2 is a perfect decimal, right? It's 4.5. It doesn't keep going and going. So because of that, you can just write it as 4.5. So this is x minus 4.5. If you want to write it as 9 over 2, that's fine. You can write it as a fraction. I wouldn't... It doesn't matter to me. The only thing that I would keep in mind is that when we subtract this piece squared, okay, when it's a fraction, if you would put 9 over 2 in here, you would be subtracting 81 over 4. You square the top and the bottom. In this case, 4.5 squared is 20.25. So again, a perfect decimal. So there's not really a good reason for not converting it to a decimal. It's kind of up to you. I think a lot of you are more comfortable with decimals than fractions. Then we subtract 7. We get x minus 4.5 squared minus 27.25. Okay, and if we wanted to solve for the roots, we would set this equal to 0. And we would just do everything that we did up here. Okay. Okay. So let's do completing the square with an a. That's not equal to 1. Okay. And I'm going to keep the numbers really nice and simple here because my goal is just to get you to understand how to complete the square with an a that's not equal to 1 with an a greater than 1, not to have you do fancy algebra. I'm not as concerned about that in this case. Okay, so when a is greater than 1, so you're going to do everything the same way. So let's say that we have 2x squared plus 10x, no, plus 12x minus 3. Okay, so as we do this, I'm going to put down, the steps. So these are the steps for completing the square. When a is greater than 1. So the first thing that we're going to do, so it's really only 2 extra steps. The first thing that we're going to do is we're going to factor out the a from the first 2 terms. So you can see here that the a is 2. So we're going to take this 2 and we're going to factor it out, but only from the first 2 terms. So it's going to look like this. And I'm going to use brackets instead of parentheses, just because we're going to have to use parentheses at a certain point, and I don't want you to get the parentheses confused. Brackets are the same thing as parentheses. It just helps you differentiate between what's being opened and what's being closed. So we get x squared and then plus 6x. And this c just gets carried down. So I'll put that in parentheses. You just carry down the c. Now everything is the same. All we're going to do is we're going to complete the square of what's inside the brackets. And everything else gets carried down. Everything else is that a that you factored out and the c. Okay, so what does that mean? This 2 gets carried down. Then we're going to complete the square of what's inside the brackets. And we carry down the minus 3. So we're completing the square of just x squared plus 6x. Well, we draw our parentheses. Inside our parentheses, we take this b value and we divide by 2. That gives us x plus 3. And then we have to subtract the extra piece. And the extra piece that this creates is 9. Notice we're always subtracting. Now there is no extra c value. We brought the c value down to the end There is no c value for x squared plus 6x, so we don't have to carry that down. This is it. X plus 3 squared minus 9 is x squared plus 6x. So we completed the squares. So now all we have to do is redistribute the a. So we're distributing the a to this first term here, and then to this second term. Okay. When we distribute the a to x plus 3 squared, all we're doing is we're putting the 2 in front of it. So it becomes 2 times x plus 3 squared minus 18, and then minus 3. So the most typical mistake is people forget to distribute it to the constant. They only distribute it to the x plus 3 squared. And now your very last step is just to combine like terms. So what does this give us? It gives us 2 times x plus 3 squared and then minus 21. And we're done. We completed the square. So we only had 2 extra steps here. We had to do this first part where we had to factor out the a, and then we had to redistribute the a back in, okay? But everything else was the same. We still completed the square of the inside, and then we combined like terms at the end, okay? So it's 2 extra steps. Let's solve for the roots. And again, this is not really any different than what we've been doing, okay? So if we solve for the roots, what we're saying, and in questions, you won't always be asked to solve for the roots. Sometimes you'll just complete the square. So we're going to take 2 times x plus 3 squared minus 21, and we're going to set it equal to 0. So once again, we're trying to isolate x, which means that we're trying to isolate what's being squared here. So we add 21 to both sides. Okay, this gives us 2 times x plus 3 is equal to 21. Sorry, 2 times x plus 3 squared. Now we can't take the square root yet because the 2 is not being squared. So we have to divide by 2 first. Okay, and this is always the same. You're always going to add or subtract your constant from both sides. You're always going to divide both sides by your a, and then you're always going to do plus or minus the square root. So this gives us x plus 3 squared is equal to the square root of 21 over 2. I would leave this as a fraction. Don't turn it into a decimal. Okay, leave it as a fraction. And then, sorry, we take the plus or minus square root of both sides. Which leaves us with x plus 3 is equal to plus or minus the square root of 21 over 2. And then we just subtract 3 from both sides. And just like with complex numbers, you should put your negative 3 in front of the radical. That way it's not confusing as to whether or not it's under the radical, right? So if you write it like this, you never have to worry that it's going to look like it's 21 over 2, square root of 21 over 2 minus 3. You don't have to worry about whether this minus 3 is under the radical, because here it's very clear it's not. Okay, so we would write it like this. Put your number first, always. Notice we've always been doing that. Okay, and this is our final answer. Now, we don't typically like square roots over a denominator. Right now, I will let you leave it this way. When we start to talk about how to get rid of that, then I'll say this is not okay. So for our polynomials unit, this is okay. You can leave it like this. And again, leave this as a fraction. Don't turn this into 11.5. Okay? Or, sorry, 10.5. Don't do that. Leave it. Okay? So up in the other problems, when we had a number that was odd, we said you can divide by 2 and turn it into a decimal. Don't do that when you're solving for the roots. Okay? So let's do another one. And if you feel like you might be ready, try it yourself. Okay, remember you can always stop these videos and try the problems yourself. So let's do 3x squared plus 12x plus 1. Okay, so once again, what are we going to do? We're going to factor out the a, but only from the first two terms. The reason why you only do it from the first two terms is that there's no reason to wind up with an extra fraction that you're dealing with, okay? So you don't want to have to deal with a 1 over 3. So it saves you a little bit by just dividing the first two terms, okay? So we're going to factor out the a from the first two terms, and we get x squared plus 4x plus 1. We have not completed the square. You cannot redistribute. Then we're going to complete the square of what's in the brackets. Do not forget any of these steps. Just practice, practice, practice. You can always make up your own problems too. And I have plenty of problems for you. If you want extra problems, just send me an email. So here, this means that we're completing the square. So notice we're bringing down the 3 and the 1. Excuse me. So the 3 gets brought down, and we're completing the square of what's inside the parentheses. The plus 1 gets brought down. Okay, so we're only completing the square of the x squared plus 4x. That means that we are writing out parentheses with the square. And what goes in here is x plus 4 divided by 2, or x plus 2. Now we need to subtract the extra piece. So the extra piece is this number squared. So we're subtracting 4. Okay, notice we always subtract. Now we redistribute the a. So that a gets distributed both to what's in the parentheses and the negative 4. So be careful here. It doesn't actually get, the only thing that you do to distribute it to the x plus 2 squared is stick it in front because you're multiplying. You have to do the exponents first. Some of you are forgetting this. Exponents come before multiplication. So the x plus 2 has to be squared before you can multiply by 3. Then we have minus 12 plus 1. Combine like terms. This gives us 3 times x plus 2 squared minus 11. We have completed the square. We'll do another one where we solve for the roots. I'll do another example of completing the square. I won't solve for the roots in that third example. So we'll see if you can do it. You should be able to do it on your own at this point. Remember, the only extra piece is this division by 3. So we set it equal to 0. Again, you have to get rid of the 11 first. This process is always the same. Add 11 to both sides. You get the 3 times x plus 2 squared is equal to 11. We haven't wound up with any negative square roots just by weird coincidence. But again, if we had had a negative square root, we would have to pull out an I. We divide by 3 on both sides. Okay, that gets rid of the 3. And what that allows us to do is to take the square root of both sides. Remember, leave this as a fraction. Leave it as 11 over 3. Okay, so we do plus or minus the square root. We can only do plus or minus the square root if one side, there's nothing else other than the square. So this leaves us with x plus 2 is equal to plus or minus the square root of 11 over 3. And then we just subtract 2 from both sides. And put the 2 in the front. So we get x equals negative 2 plus or minus square root of 11 over 3. And it is okay to leave it like this for now. Okay, I'm going to do 2 more examples and then we'll call it a video. And I won't solve for the roots. We're just going to complete the square because that's where people really struggle. So let's say we have 4x squared plus 32 x minus 6. Okay, so once again, we start by factoring out the a from both of the first 2 terms. So the point of this is that you don't have an a that's greater than 1 anymore because we just have x squared plus 8x now minus 6. Okay, so we're going to complete the square of what's inside the brackets. So that means that the 4 just gets carried down. Nothing is happening to the 4. By the same token, nothing is happening to this minus 6. Okay, we're just leaving those off to the side. We're completing the square of what's inside the parentheses. Inside the parentheses brackets, we're going to have x plus 4. Okay, so we took this b value and we divided by 2. So you're only paying attention to x squared plus 8x. Everything else block out of your mind. Then we have to get rid of the extra piece. So the extra piece from here is 16, because that's what 4 squared is. Now we can redistribute our a. So we're following the same exact steps every time. That's going to leave us with the 4 on the outside x plus 4 squared. Okay, remember the 4 remains on the outside because we need to do exponent first. X plus 4 would have to be squared first. Do not forget to distribute to the 16. So we get minus 64 minus 6. Combine like terms. 4 times x plus 4 squared minus 70. Okay. Okay. We're going to do one more, but this time I want you to pause the video once I write down the problem. Do it yourself. Make sure that you understand how to do it. So let's say that we have 5x squared plus 60x. Let's make it a minus because we haven't done a minus in a while. 5x squared minus 60x. Plus 32. Okay. Certainly this would not be fun to factor, okay? Because you would be doing, even if it were factorable, and I'm pretty sure it's not, you would be doing 5 times 32 first. That would give you 160, and you would have to look at all of the factors of 160. That would not be pleasant. So even if this were factorable, it might be very difficult to factor. So it's worth doing completing the square. You can see completing the square is always just these 4 steps. Okay. So we have 5, and then we're factoring it out from the first 2 terms. So we get x squared minus 12x plus 32. That 5 and that plus 32 just get carried down. We're ignoring them. Okay, they're not useful in this step. So the only thing that we have to do is complete the square of what's inside. And notice I've been giving you pretty nice numbers, okay? I've been trying to make these divisible by 2 just to make your distribution easier. So inside here, we're going to take our b value of what's in the parentheses. So we're not taking this value. We're taking this one, okay? We're only looking at this. Forget about that top one right now. So 12 divided by 2 is 6. So we're going to put x minus 6. And then we're going to subtract our extra piece. So remember, it's always a minus. It's always an extra piece. It's never that we're short a piece. Right? We're always creating a square, and we always have this extra piece. That's why I showed it to you geometrically, so that you can see that you always, when you create that square, you always have that extra piece. It's not that you're trying to fill in, okay? So we always subtract minus 36. Okay, so now we have to redistribute this 5. Notice, again, it's the same steps every time. The 5 gets redistributed to whatever we squared and to our constant. That's going to leave us with 5 times x minus 6 squared. And then we have to take 36 and multiply by 5, which gives us 180 plus 32. And then we're going to combine like terms. And that's going to give us 5 times x minus 6 squared minus 148. And if we solve for the roots, it's not that much fun because we have to simplify the square root of 148 if it can be simplified. But this is it. Okay, I have a little bit more room on the page, so let's just do one last one. Let's do 2x squared plus 28x minus 5. Okay, so once again, we factor out the 2 from the first 2 terms. Even if the last term is divisible by 2, I wouldn't do it. So even if this had been a minus 6, I would still only factor it out from the first two terms. And let me turn that into a bracket. So x squared plus 14x minus 5. So remember to pull it out of the middle term too. Okay. So then this 2 and this minus 5 get carried down. And we're only going to complete the square of what's on the inside. So that leaves us with an x plus 7 squared, and then we're subtracting 49. Always subtract. Okay. Then we have to redistribute the 2. Again, if you look at the two problems above, it's exactly the same thing. You're seeing the same thing repeated every time. The 2 stays on the outside of the parentheses. Uh, 49 times 2 is 98. And then we combine like terms. So 2 times x plus 7 squared. And then minus 103. And again, you can solve for the roots, add 103 to both sides, divide both sides by 2, plus or minus square roots, subtract 7 from both sides. So you can solve for the roots for all of these. Okay, and that's it for completing the square.